So we're in your geometry and we're in section 6.6, the measurement of the circumference of a circle. Circumference of a circle is the measure around the circle. So it says the method used in measuring any segment of a straight line is to select a unit straight line and apply it to a given segment. But you can't do this with a circle, can you? Because circles do not make straight lines. And so we have to have another way. I suppose you can get a string and try to go around it. That would be a good way. A method for finding the approximate length of a circle, which is both accurate and geometric, will now be considered. So we're going to inscribe a square in a given circle, then form a regular inscribed polygon of double sides, and we're going to keep doubling and doubling and doubling the sides, right? Suppose that this process of doubling the number of sides of the inscribed regular polygon is continued indefinitely. It is apparent that the perimeter, the apothem, and the included area of the successive polygons are steadily increasing in magnitude and are getting closer in value to the circumference, the radius, and the area respectively of the circle. It's basically making now more and more polygons. Here you got, if you have this polygon, this clear, keep going more and more, you're going to get closer to the size of that circle or what the circle represents, right? So basically here in italics, it says any regular or any relation between the perimeters, the apothems, and the areas of regular polygons that remains true as the number of sides successively doubled is true is also between the corresponding parts of the circle. So basically saying, if you double it, you're going to get closer to that circle size, right? So from these considerations, we infer without proof the following things. Let's see what they're talking about. If the number of sides of a regular inscribed polygon and of its regular circumscribed polygon is indefinitely increased. So the more you increase, you can go on indefinitely. More and more sides until you have 1,000 sides into almost the circle, but still it's indefinitely. So their apothems approach the radius of the circle as a limit. So the apothems keep going until the radius of the circle is its limit. Their perimeters approach the circumference of the circle as the limit. So basically the circumference of the circle is going to be the limit. You go indefinitely, you're going to get to that circumference of the circle. Their areas approach the area of the circle as a limit. So basically it's turning into a circle, is what they're saying. So, and this here in Theorem 82 said that the circumferences of two circles are in the same ratio as their radii. So if you have two circles and they have the same radii, then the circles are going to be ratio, like one big circle and a smaller circle, they're going to be the same ratio as their radii. So we already knew that one. Going on to the corollary 82 here. So basically here we have two circles, and here's the radius of our radius and this radius. It's going to be, the whole circle is going to be, this circle is going to be the same ratio as this circle to this circle as the radius is to this circle. That's the ratios are going to be the same is what they're saying. Got that there, top? I don't know if you see that. Corollary 82.1 says the circumferences of two circles are in the same ratio as their diameters too. So if their radius are in the same, then a diameter is going to be twice the radius. The diameter goes all the way across, right? So the diameter are going to be in the same ratios too. So here we have, basically if you have this circle and this circle, and you have the diameters are going to be in the same ratio, D to D1 right there. A ratio of any circumference to its diameter is constant. Okay, this is important because it's constant, it doesn't change. So the ratio of any circumference to its diameter is constant. What do we call this constant? We can have a constant for it. That means the ratio of the circumference to the diameter. The circumference is the distance around the circle to the diameter, which would be, this would be radius, the diameter would be across, right? Like that. So that would be constant. You know what you call this constant? Give you a clue. Pi The circumference of the circle to its diameter is called pi. And a long time ago, they figured out pi is 3.14, and it goes on. I'm sure you learned about pi. What does pi look like? Pi looks like this little weird symbol right here, this little of pi. So now we have, just remember, the ratio of the circumference to its diameter. Circumference compared to diameter is constant, and this constant is going to be pi, right? So going on to corollary 82.3, the circumference of any circle is expressed by the formula circumference equal 2 pi r, so 2 pi r, it's important, or pi times the diameter. So circumference is pi times the diameter. Circumference is constant, equals pi times the diameter with pi. Or if you don't want to use a diameter, you can use 2 radiuses, 2r pi. You've learned this before. Corollary 82.4 says the length of an arc of a circle in linear units is the circumference as the number of degrees in the arc is 360 degrees. So if you have, basically this little 0 thing means whatever you put in there. That's just a blank, you know, you're gonna put in your number that you have. So it says the length of an arc of a circle is to the circumference as the number of degrees the arc is. So you have S over C equals how many degrees it is over 360 degrees. And that'll be the length of the side, the length of the arc, and being that arc length is the circumference. So this is going to be another formula you need to remember. Okay. There's some other questions here, but we're going to go on and stop there and do our quiz. Quiz is very short and it's not really hard. So 47. The first says, find the circumference of a circle that has a 6-inch radius. These are pretty easy because we know the circumference equals 2 pi r, or circumference equals diameter times pi, because there's 2 radiuses in a diameter, right? Well, we're going to use the radius here, so we have circumference equals 2 pi times 6, and we just put the 6 in. So circumference is going to equal 2, and then if we have pi, we're going to put down pi as equal 3.14. It goes on, right? It's indefinite number of pi in the circumference times, and of course, times 6. The radius is 6. So 2 pi r, there's 2 and 6. 2, and the 6 is the radius, and then you put in pi. So make sure you go ahead and show your work here, but we have 3.14 times what? 6 times 2 is 12. So 12 times 3.14, and I figured it out here, which I figured it out wrong in the beginning, so I had to change it. But anyway, I did my multiplication here. So you do your multiplication, you'll get 37.68. So the circumference is going to be approximately, we'll put approximately here because of pi, 37.68 inches. That's going to be the circumference of that circle. All we did was plug in 2 pi r. Easy, right? So now number 2, find the length of 60-degree arc at the circle in number 1. So if we have a 60-degree arc, we're going to compare that to 360, right? So here we have the arc. What's 60 divided by 360? Well, if 60 is 1, and it goes in there 6 times, of course, 60 times 6. So we can reduce this fraction here. We're just reducing this fraction, and this is in degree, to 1/6. So now we know, oh, okay. So now this arc is going to be 1/6. So how big is this arc going to be? So we take in pi, this is what we have in inches here, and this is a whole circle, and you just divide it by 6, because we have a 1/6 of the circle right here. So we have 37.68. This is what we learned up here. And we divide it by 6, which I did here, goes into 6.28. So 6.28 inches is going to be the arc. So the arc is only 60 degrees, and the circle is 360 degrees. So this is going to be 1/6. And so 1/6 is 30. This looks like around 36, and this looks like 6. It looks like 1/6 of that, right? And it is. Number 3. If two circles have circumferences of 12 pi inches and 18 pi inches. Now this one they didn't figure out. They just leave the pi. They don't transfer 3.14 in this one because they didn't want to. So you have two circles, and one circle has 12 pi and the other has 8 pi circumference. That's circumference is the distance around the circle, right? So one is 12 pi and one is 18 pi. They want to know the ratio of those two. How easy. So basically the ratio is going to be 12 pi to 18 pi. So we can actually get rid of the pi's there. And then we got 12 to 18. We can reduce that. 6 goes into 12 2 times and 6 goes into 18 3 times. So we can reduce that to 2/3, right? And this is going to be our ratio. 2/3 answer. We don't need to have inches or anything there because it's just a ratio of these two. One's bigger, say this one's bigger than the other one a little bit. Those are not, they look like I don't draw circles very well. Let's go on to the next one. Find the diameter of a circle that has a circumference of 20 pi. Well, this is another one we just plug in. I told you this quiz is pretty easy. So circumference equals 2 pi r, right? So we have circumference equal 2 pi r, or we can have circumference equal diameter because two radius is the diameter. So the diameter now, we want to find the diameter. So we'll probably we have to use this one because it has a diameter. We don't have to, but because we're not dealing with radiuses anymore, we're dealing with a diameter. So now we have 20 pi. Look at this, it's 20 pi. So diameter is 20. So now we know, because the diameter is 20, that our 20 pi would be 20 inches. We didn't even have to do anything. We just filled in 20 pi. So basically, circumference is equal 20 pi. Well, if you'd have 20 pi, d would be the diameter, which is 20 inches. All I did was plug it in, and there it was, the answer. Diameter, 20 inches. Okay? So that's it for this section, and we'll go on to the next quiz, next section.